In this question, it is given that the value of limit of this expression where n tends to infinity is, you have to find the correct choice. First of all, we will have to find the sum of all the terms in the numerator of this expression. Here 2 positive, 1 negative, 2 positive, 1 negative are there. Therefore, the first thing which comes in mind is make groups of 3 terms. We can say that first term of all the groups, that is 1, 4, 7 up to 3n minus 2, they are forming AP. Second term of all the groups are also forming AP. Third term of all the groups are also forming AP. And we know that if there are two APs, if I add the corresponding terms, the new sequence I get is also an AP. Suppose there is an AP having terms 2, 5, 8, 11, 14 and so on. There is one more AP, say 1, 3, 5, 7, 9 and so on. If I add the two APs, I will be getting 3, 8, 13, 18, 23 and so on. You can see very easily when I have added the corresponding terms, the new sequence I have got is also an AP. Keeping this concept in mind, I can surely say that because 1, 4, 7, because keeping this concept in mind, it is clear that 1, 4, 7 and so on are in AP. 2, 5, 8 and so on are in AP. 3, 6, 9 etc. are in AP. Minus makes no problem. Even you can say minus 3, minus 6, minus 9 are also forming AP. And therefore, sum of all the terms in every group will also form an AP. Sum of all the terms in first group is 0. Sum of all the terms in second group will be 3. Sum of all the terms in third group will be 6 and so on. And sum of all the terms in last group will be 3n minus 3. Hence, sum of all the terms in the numerator will be equal to sum of all these terms. And clearly this is 3 into n minus 1. Now it is easy to see that this sequence has n terms and first term 0. Therefore, sum of all the terms will be n by 2 into first term plus last term. That is equal to 3 by 2 into n minus 1. Hence, I can say this is equal to limit n tends to infinity 3 by 2 into n minus 1, and taking n square common from the denominator, I get under root 2 plus 4 by n plus 3 by n to the power 4 minus under root 1 plus 5 by n plus 4 by n to the power 4. That is equal to limit n tends to infinity 3 by 2 into 1 minus 1 by n upon under root 2 plus 4 by n plus 3 by n to the power 4 minus under root 1 plus 5 by n plus 4 by n to the power 4. And now it is clear that as n tends to infinity, numerator tends to 3 by 2 and denominator tends to root 2 minus 1. That is, I get 3 by 2 into root 2 plus 1 upon 2 minus 1. Therefore, the answer is 3 by 2 into root 2 plus 1. Hence, I can say third choice is the correct choice.